All right, guys. So today we're going to cover Unit 2, Lesson 5, and we're going to talk about exponent law. Okay, so the kind of title got chopped off on a different page, so there you have it. The next instructions is evaluate. Evaluate's another fancy math term for saying solve. So we're just going to figure out what all of these equations will equal to, or these expressions. We'll go from there. Okay, so we have 5 cubed times 5 to the power of 4, right? So if we wanted to solve this, the simple way, what we're going to start with, okay, is we're just going to break it down to its two different sections, solve it, but we're going to find some shortcuts that are going to make our lives a lot easier throughout the rest of this unit. So let's start with this. So 5 cubed is 125 times 5 to the power of 4, and we get 625. Okay, if we multiply these together, that's 125, we get 78,125. Okay, so a few steps, not too bad, no problem here, right? 5 to the power of 7, we get also 78,125. Okay, over here we can look at 4 to the power of 7, which is 16,384, and 4 squared is 16. All right, let's see at how that all works out. 16,384. We get a massive number of 262,144. And if you're noticing the pattern yet, 4 to the power of 9 will also equal 262,144. Why is that? So we have 5 to the power of 3 times 5 to the power of 4 is the same as 5 to the power of 7. It's almost like we can add these exponents together when you're multiplying powers. Very interesting. All right, so why don't we put that into an actual written rule, and this is something you'll be able to use for the rest of your math year. Okay, so the rule goes for product, so that's when we multiply, right? A product is multiplication. So when multiplying powers, the same base, very important, same base, the answer is the base with the exponents added. Okay, so we add these bases. So here we could say a to the m plus a to the n. These could be the same, they could be different, it doesn't really matter, equals good. That's just not going to happen apparently. There we go. A to the m plus n, right? So let's practice this over here. So we have 5 to the power of 3 times 5 to the power of 4. Okay, so if we take 5, our a, to the power of 3, and we add our next power, exponent, to the power of 4, that gives us 5 to the power of 3 plus 4 equals 7. That's it. Okay. The two main rules to keep in mind is you have the same base and we're multiplying. All right? Doesn't work in addition or subtraction, and division has its own rule, which we're going to look at and is going to make a lot of sense when we start getting. Okay, let's do it one more time. So we have 4 to the power of 7. We're multiplying, so we can add our exponents because we have the same base, and this will equal 4 to the power of 9. Awesome. All right. Another way we can kind of show this work, right, is if we expand. So here we have 5 to the power of 3, which is 5 times 5 times 5. Okay. And then we can multiply that by 5 times 5 times 5 times 5, right? And if you got rid of these brackets, it'd be the exact same equation because all of its multiplication. So if we do this, we would get some answer. But this is kind of the proof in the pudding, so to speak, of why we can add it. We have 1, 2, 3, 4, 5, 6, 7, 5 bases. And so then we can simplify that into a power where we have 5 to the power of 7, which is the same thing as 3 plus 4, which we've just done over here. Okay, I hope this is making some sense. Again, as always, if it's not, let me know. All right. So this is where we're going to make things a little bit more complicated, but not too bad, right? We're going to add some negative integers. We're also going to add some stuff where the negative is maybe separate. So it's really, again, always paying attention. What is my base? That's the first question you should ask when we're doing these expressions with powers. Okay, so first things first, we have 27 and 27. They're being multiplied, so we can add their exponents. So we have 2 plus 3, and that equals 27 to the power of 5. Okay, over here, what is our base? Minus 3, because it's all in brackets. We know that's all contained. So we end up with negative 3 to the power of 3. And even if there's no multiplication sign, if you have brackets, we know that they're all multiplying. So here we have 3 plus 2 plus 4, and all of this is negative 3 to the power of 9. Okay, all right, let's keep going with this. I think we're on a roll. All right, so here, 6 to the power of 3 times, 3 to the power of something. We can't use our trick because we have 2 different bases, okay? So now what we're stuck doing is what is 6 to the power of 3? Well, 6 to the power of 3, 216 times what's 3 to the power of 6? 729. Okay, and then we can multiply these two together, which is 157,464. Okay, so when we have numbers that have the same base, we can still solve this problem, but there's no shortcuts. We have to do it the long way. Okay, so let's get over here. So we have multiplication, we have the same base, so we can use our rule. So we have 2 to the power of 3 plus 15 plus 2, which gives us 2 to the power of 20, right? If I ask you to solve or evaluate, okay, other than simplify, I would expect us to actually go through the step of figuring out what 2 to the power of 20 is. In this case, we have 1,048,576. Okay, if we were going to be solving this problem. I'm not going to make you do that most of the time. Again, because some of these numbers get pretty massive, and that's not really what I need to test you. If you can put this into a calculator. We've already done that. We've moved on from there. We've graduated. We've grown up. So much has happened in the last few days, and we're going to keep going with that. Okay, so do note though, as I mentioned previously, if we're adding and subtracting powers, there is no special rule for this. You have to do it the good old-fashioned way, one step at a time. So we'll kind of look at what that might be when we get there, all right? So here, we have 8 to the power 2 plus 8 to the power 3. Can we add our exponents? No. Because we're adding, it changes the rule. So here we have 8 to the power of 2, which is 64. And we just do it the good old way, right? 8 to the power of 3, 512. We add these together, and we get 576. Okay, same thing down here with our Next problem, it's a subtraction. We can't use our rule, so we're just going to solve this classic mode. 5 to the power of 4, 625. So we get 125 minus 625, and our final answer is negative 500. Okay? All right. Over here, we kind of have a bit of a mix. How do we do that? Same thing as always. We think of bed mass mostly. So here we have two terms, same base of -2. Exponents multiplying, we can use our trick. So here we have -2. The power of 2 plus 3, all of that, -2 power of 4. Okay, here we have -2 to the power of 5. Don't forget your brackets, right? Because if you write it without brackets, technically that negative is on its own, and that's not what we're showing. Okay, to -2 to the power of 4. Okay, so here we have, in brackets, -2 to the power of 5, -32, -2 to the power of 4 is 16, okay, and all of that is equal to -16. All right, one last problem here, and then I think we're done. Okay, so here we go, 2 to the power of 4 times 2 to the power of 3 minus 2 to the power of 0 times 2 to the power of 3. Okay, so we have two sections here that we can simplify, and then we have to combine them by subtracting, no problem. Okay, so 2 to the power of 4 plus 3 minus 2 to the power of 0 plus 3, 2 to the power of 7 minus 2 to the power of 3. Over here, 2 to the power of 7, 128, minus 2 to the power of 3, which we know to be 8. So our final answer is equal to 120. Okay, I hope this was helpful. I hope this clarifies a few things for you guys. And we're going to keep moving along. Have a good day.